All right. You guys are this one. All right, so here are the same warm-up questions that you had in your Nearpod today. It says to solve 45 equals 6w minus 9. Okay, so if we remember back with our equations, we do want to split the problem so we have a left and a right side. And the first thing that we would want to do is cancel out the plain old number, in this case the minus 9. And we cancel things out by doing the opposite. So I add 9 to both sides. On the right side, it cancels out. And on the left side, 45 plus 9 would be 54. And now I have 54 equals 6w. My goal is to get w by itself. And I'll leave that there. And to get rid of the 6 that is smushed next to the w, it would mean that it's 6 times some number equals 54. So remember, we always do the opposite. So the opposite here would be to divide by 6. That cancels it out on the right side. And what I do to one side, I do to the other. So 54 divided by 6 would be 9. So 9 would equal w. We're going to be getting into equations very, very soon. So this is just kind of a refresher, a review. This next one may look a little different. You probably didn't have to deal with any equations that had a square in it or the exponent in there. But we have dealt with some squares and square roots, so that's why that is there. And it's leading us into our next topic as well. We have 9 squared plus r equals 94. So same rules. I need a left and a right side. My goal is to get r all by itself on the left side. So I want to get rid of the 9 squared. Well, actually, the first thing I would do is go ahead and solve for whatever 9 squared is. 9 squared is 81. So now it doesn't look as crazy. 81 plus r equals 94 now. And now when you look at it, it's really not that bad, okay? It's probably really easy. We still want the r, so that what we need to cancel out is the 81. So I do so by subtracting both sides by 81. Because that cancels it out over here, leaving me with just r. And 94 minus 81 would be 13. Final answer. R equals 13. All right, questions on those two problems so far? Okay, I don't see any action on the chat or any hands being raised, so keep going. All right. We do have some visuals. They are very short. So what I want you to do, since you guys are in the Zoom, I want you to, because I don't think the sound is going to be great if I play it. I'm sorry, who just spoke up? Okay, so I'm going to let you guys take about, it should only take about 3 or 4 minutes, because I know one video is like 40 seconds long, and the other video is about 2 minutes long. So I'm going to give you about 3 or 4 minutes. I want you to play each one of those videos. They're in your module. It should be the next thing in there that says Pythagorean Theorem videos, I do believe is the title of it. Go ahead and go play and watch those videos. Let me see here. So let's keep going. If you didn't have time to finish watching those videos, you may still have time right now while I have the ISN page up. Or you may go back and watch them later. There's some pretty neat videos, pretty short as well. So today we are starting Pythagorean Theorem, okay? It's probably page 7 in your ISN if you've been following along. It may be something different. Just make sure that whatever you are putting down in your table of contents, it matches what's in your ISN. Okay. All right, so here's what you're going to be writing as your notes. So it's pretty short. I did load the little bit longer page. If you are able to print it, great. You can print it and use that as your notes page. Take notes on it today and then glue it in your ISN. Or if you cannot print, it's really not a whole lot to write today. It's a little bit of writing and a little bit of drawing, such as drawing the diagrams, the right triangles and the squares. Pythagorean theorem, the theorem itself, states that a squared plus b squared equals c squared. That should be real big on your notes page. Make it important. It is important. It is the theorem. We will use it to solve for the missing side of a triangle or possibly the missing area of a square. All right, here is the notes page that was loaded in Canvas. So this is the one that some of you might have printed. It is called Pythagoras' theorem and can be written in one short equation. That theorem, the equation, is a squared plus b squared equals c squared. And here's a visual of that. So if we look at our squares, it means the area of this little green square plus the area of this a little bit bigger purple square would be equal to the area of the largest square, the red one. And when you put these three squares together, like you see on the left side of the screen, you'll notice that in the middle, it forms a right triangle. Just like you saw as your diagram in those videos. So if you're having to draw this or write your notes because you aren't able to print, you need to be writing pretty much everything you see on the screen. Draw all the visuals. Whatever is on the board, you should be getting in your notes page. Okay, and now let's talk about some of the vocabulary that we'll be using when we're talking Pythagorean theorem. Okay, C is the longest side of the triangle. So as in C in the theorem, it is the longest side of the triangle. So we also call that the hypotenuse. Notice it labeled there on the right triangle diagram that's at the bottom of the screen or at the bottom of your notes page. And it's also always across from the right angle. It's the longest side on the triangle, and it's always the side that's across or opposite of the right angle. Another vocabulary word that we use while we're talking Pythagorean theorem and right triangles is legs, okay, or leg. Leg is side A and side B. So part A and part B in the theorem. It's the two sides that connect to the right angle. And they definitely are going to be shorter than your hypotenuse. I generally like to say A is my shortest side, B is my next longest side, and C is the longest side. I just usually like to go in order. You'll notice that when we start doing some problems. I want you to write and draw this in your ISN. I'll give you maybe a couple more minutes to do that for those of you that are having to do a little bit more writing. Now we're going to go ahead and look at actually using this theorem or this formula. So here's our practice problems. Using the Pythagorean theorem, decide whether or not the set of squares will form a right triangle. Yes, it's a typo, there should be an S there, squares. So let's look at this first one. We have the information about the three squares is saying that the side length of this one is 36 units. The side length of each side of this square is 39 units. And the side length of the smaller one is 15 units. So if we were to manipulate these squares and move them around on the paper, and put them in together in a way where they would form a right triangle, would it form a right triangle? So the way that we prove that is Pythagorean theorem. So a squared plus b squared equals c squared. And I have my three sides. All I'm doing now is plugging that in. So I'm going to say, or I like to say, that my smallest is my a, so that's a. My next biggest would be b, so 36 would be b. And therefore, my longest side, it should always be c. The longest side has to be the c. So now we're going to plug this in. 15 squared plus 36 squared, will that equal 39 squared? Okay. Most of these are a little bit bigger than the perfect squares that we had on our chart, but one is not. So 15 squared, tell me what that is in the chat, please. What is 15 squared? That's what you're doing. You're just solving this equation, which is why that was part of our warm-up. Very good. Thank you. 225. Okay, this one might require the use of a calculator, or you could multiply it out by hand. But right now, tell me what's 36 squared. Put that in the chat. Thank you. Some of you are super quick. Thank you, Ty. 1,296. And then again, 39 squared. Tell me what that is in the chat, please. Very good. Yes, 1,521. So you are trying to prove whether or not this is going to be a true statement. So now we simplify what we can, and we can add that. 225 plus 1,296. Tell me what that is in the chat, please. Very good. Thank you, Ty. It is 1,521. So we're just simplifying. So I'm going to bring down the last part. And because that's a true statement, 1,521 is equal to 1,521. We would say that, yes, this is going to form a right triangle. So if I were to move these triangles around and put them together, edge to edge, in the center, it would form a right triangle like we saw in our diagrams and like we saw in those videos. Okay, let's talk about that water video that hopefully you had time to watch. That was the really short one, right? Where they had that special kind of mechanism that held water in those squares. And you notice that when she turned the wheel, that the two smaller squares started to fill up the largest square. And it filled it up exactly. And then she went back. She took what was in the large square and let it fill up the two smaller squares, and it was exactly the same amount. That's what we're proving right here in these diagrams. That's what Pythagorean theorem is proving. So let's look at example 2. This one's a little bit different because you'll notice that my numbers here have the little square. This means 196 square units. This is the area of this square. So it's going to be a little different than the last problem we did. This one is also the area because it gave me these square units. This one, it's telling me the area of this square. So that means it changes things when we put that in Pythagorean theorem. Still using it. That's the first thing we want to write down. A squared plus b squared equals c squared. We still say that, or I like to say that the smallest square is my a squared. So my smallest square is the 196 square unit area. Guys, this is a squared. So I plug in 196, just 196, because they've already squared it. They've already done the area of the square. Okay, I'm emphasizing that because we've had issues with people getting that confused in years past. So I want to make sure that that's clear, especially since y'all are not in the classroom with me. My next smallest square, the area of that, is 2,304, and that is my b squared. So that's all I write into the formula. And then my last one, the biggest one, this is c squared. So I just write down 2,500. And this actually means that there's a little bit less work for us to do. Okay? All I have to do is simplify what's on the left side of the problem, meaning all I've got to do is add those two numbers. And I do get 2,500, which is equal to 2,500. So yes, this would form a right triangle, which is what's behind that little green square, or rectangle, sorry. Very good. Okay, so let's keep going. Got a few more of these proofs we're going to do. So let's look at this one. We're doing the same process. Are these going to form a right triangle? Okay, so if we look at this one, we can count the squares. So we know that this is 9, that's my smallest one, and that is a squared. Okay, my next biggest one is the one on the bottom, and this one is 16 square units. So this is my b squared. I don't remember if this is an issue with the page. Okay, so what happened with the page? Okay, no, this really isn't a square, but let's go ahead and form that square. I think we need to add 2 more rows. And you don't have to draw this, you can just follow along with me. You want to draw it, great. Okay, you don't have to draw the little squares. Just label that this would have an area of 25 units. So this would be c squared. So when I go to plug this into Pythagorean theorem, which is a squared plus b squared equals c squared, it's a real easy theorem to memorize. It is given to you on your star chart, but I would assume, like usual, most people have it memorized pretty quickly. And remember, a I like to use as my smallest, and they gave us the area of it, so it's just 9, not 9 squared. It is just 16 for b, and we would plug in 25 here. So in the chat, answer that question that we've been doing. Will this be a right triangle? Does it prove itself to be a right triangle? Okay, very good. I got a couple of responses. All you're doing here is you're simplifying the equation. 9 plus 16 is 25. And 25 does equal 25. So yes, this would form a right triangle. Let's look at the next one. So it's giving you the side lengths. We don't have completed squares this time. So the side length is 1, 2, 3, 4, 5, 6. I'm going to label it on the inside of the triangle. And this one on the bottom would be 2, 4, 6, 8. And 2, 4, 6, 8, 10. Okay, so if I look at, we should have done it that way. The triangle, is this really a right triangle? The way that you prove that is Pythagorean theorem. So I want you to try this one now. Try it. Here's a starting point. And answer yes or no after you do your work privately in the chat so that everyone has a chance to work it. All right, very good. I see my chat answers are coming in. Very good, very good. Okay, so remember I go A to C, I go smallest to largest. That's always just a way to make sure that C is always your biggest number. So 6, and it was not squared because we just knew the side length. We did not know the area. 6 squared plus 8 squared, will that equal 10 squared? These are pretty easy squares. These are smaller ones. So 36, then plus 64, will that equal 100? Yes, it does. 100 here and 100 here. So yes, those do form a complete right triangle. We've got 2 more that I kind of want you guys to try on your own. So try this one. I know it may be very small, so I'm going to go ahead and give you the areas. So we have our squares this time. The area of the smallest one is 25 square units. And this one would be 144 square units. And this one, okay, so use your Pythagorean theorem, plug in your information, your data, and prove whether or not this is going to form a true right triangle or not, and let me know your answer privately in the chat, please. Very good, guys. Yes, all you're doing, a squared plus b squared equals c squared. Smallest was 25, and it was already the area, meaning it was already squared for me. B squared would be the 144. Again, it was the area, so no need to square it. And this one, yes, that does add up to 169. So yes, it's another true Pythagorean triple. Okay, try this one. This is our last one that I want you to do on your own, and then we'll talk about your homework, which really you'll probably get done in class time because it's super short. Okay, answer yes or no in the chat once you've plugged in the values to your formula. It is not giving you the area of the squares. It is giving you the side lengths of each square. Okay, so be careful there. Remember, it's not squares. That means it's a single dimension, just the side. Okay, I already see some answers coming in. You guys are pretty quick. We got a squared plus b squared equals c squared. We do not have the areas, so this one is just c. These are the exact same size, so I'll say a, I'll say b, doesn't really matter. 4 squared, because I need to square that, plus 4 squared, will that equal 5 squared? Some of you already answered, and some of you already know. So this would be 16 plus 16, and this would be 25. 16 plus 16 equals 32. So no, this is not going to form a right triangle in the center. Okay, so we had our first no response. All right, so here's your homework, and I actually already did one of them for you because I want you to understand what I mean by showing your work. You're going to use your formula, aka Pythagorean theorem, to show your work just like you see done on number 1. This is due Tuesday, the 8th. If you can print it and complete it, great. If not, do the problems on a sheet of paper and set up your page like you see. Okay? It's really, what we did is we took a half sheet. So it's really just 6 questions, now 5, since I did number 1 for you. Okay, so if you're able to print it, great. You should be able to print that out. Do those problems on that printout. If you are not able to print, You do need to draw the triangles to the best of your ability. Number them, try to keep it organized, preferably just like you see on the screen. Show your work, just like I did for you on number 1 as an example. And complete that. You can either bring it to class completed on Tuesday. Yay, I'm going to see you guys on Tuesday in person. So you could just bring it with you to class, and we'll start that whole process of how I normally check things off in person. Or if you'd prefer, you can complete it, scan it in, and submit it in the Canvas assignment as well. Okay? So you guys have about 12 minutes to finish up that assignment. So you should have plenty of time to finish it while you're technically in class.